Dear students, I am uploading the solutions of problems from Sri Chaitanya material, that is IIT material, okay. Page number 68 to 69, problems 17 to 26 I am going to discuss, right. In this, especially I am going to make use of these fundamentals. Be careful, if position is given and he is asking velocity or acceleration, you have to go for differentiation. From acceleration, if you want to calculate position or velocity, you have to go for integration, okay. And I am going to make use of these three basic equations of motion, okay. Now, if you look at this problem, a particle starts from rest, means first of all write down the data. Starts from rest from origin indicates at t is equal to 0, x is 0 and v is 0, and he gave acceleration is mu cos t, okay, and he is asking displacement, but in one dimensional displacement is nothing but change in x coordinate, that value I need to find out. So, if you observe, acceleration is given, indirectly he is talking about x. So, from acceleration to x, how to proceed means you have to integration, okay, and it clearly shows that first you need to find out velocity, then it is easier to find out position, okay na. So, first thing I need to find out velocity. How to find out velocity means the given one is acceleration is mu cos t, okay. Now, I need velocity, so I have to write acceleration in terms of velocity by keeping in view that time term should be there, okay. Hence, the expression which I can use is only this one, okay, sorry, this one means A can be written as dv by dt, that is nothing but mu cos t. So, dv comes out to be mu cos t into dt, then integrating this equation on both sides, okay. Now, we have to think about the limits. In first t seconds refers to what? From 0 to t seconds, indicates that lower limit of time is 0, upper limit is t, and at t is equal to 0, what is the velocity that we have to see? That is 0, and at t is equal to t I will assume velocity as v, okay. Then integration of delta dv, okay, means summing up of infinitely small changes. Summing up of infinitely small changes gives us finite change, hence directly I can write this one as delta v, that is equal to mu is a constant, it can be taken out, and for cos t integration is sin t, limits are from 0 to t, okay. Then delta v can be written as v minus u, or final velocity minus initial velocity, that is mu into, substituting upper limit leads to sin t, lower limit leads to sin 0, okay. But this is given as 0, therefore, we will get v is equal to mu sin t. Now, I got expression for v. Now, I have to think how to calculate x from v, okay. Means I have to write v in terms of x. How to write v in terms of x means we know that mu is sin t, okay. Now, I have to write v in terms of x means the possible equation is this. So, I can write this one as dx by dt, that is mu sin t, then separating similar quantities you will get dx is mu sin t dt, okay. Integrating this one on both sides leads to this equation, okay. Again, integral of dx I can write as directly delta x, that is only the required one, which is nothing but displacement, and here limits are from 0 to t. If I take mu as mu is constant, we can take it out, then integral of sin t is minus cos t from 0 to t, okay. Then it is leading to delta x is equal to mu into minus cos t minus of minus cos 0, that is substituting upper and lower limits, that is leading to mu into minus cos t plus 1, hence displacement is nothing but mu into 1 minus cos t. This is only the required answer, isn't it? Now, look at the problem number 18. Here What is the given data if you observe? The particle moving in a straight line, assume that it is moving along x-axis, thereby I can represent its position by the letter x. Okay? Starts with a velocity u, means at t is equal to 0, velocity is equal to u, means initial velocity is u. Find its position, its retardation at any instant is proportional to position, means minus a is proportional to position, means x. Okay? Indicates minus a can be written as some proportionality constant into x. Okay? Now he is asking find its position when particle comes to rest. Okay? Means he is talking x is equal to how much if v is equal to 0, right? And he gave another information also, if retardation at unit position is mu, means what? If x is equal to 1, a is nothing but retardation, minus a is nothing but mu, that is the given data. Okay? Now in this relation if I substitute that, what I am getting is minus a is mu, that is equal to k into x is 1, means proportionality constant value, indirectly he is saying it as mu. Okay? So what is the given information? Finally we have acceleration is minus mu into x, and he is asking x is how much if v is equal to 0, means indirectly he is asking us to find out x from acceleration. So similar to previous problem, how to find out x from acceleration means first of all you need to find out velocity, thereby we can find out position. Okay? So how to find out velocity means here given information is minus mu x. Now I need to find out velocity. Here I have the terms a, x and required one is v. So you have to think of relationship between these three. Relationship between these three is nothing but this. So in the place of a, I can write v into dv by dx, which comes out to be minus mu x. Then separating the terms you will get it, v dv is equal to minus mu x into dx. Okay? Now integrating this equation leads to what? Before integration, further integration, we have to substitute the limits first. Okay? So initial position we will take it as some 0, then obviously final position comes out to be x, and initial velocity he gave it as u, final velocity is v, isn't it? Then integration leads to, for v, integration is v square by 2 from v to u is equal to mu is constant that can be taken out, for x, x square by 2 from 0 to x. Okay, na? And he is mentioning that final velocity 0 means this is equal to 0. So substituting those values we will get, first substitute upper limit 0 square by 2 minus substitution of lower limit u square by 2 is equal to minus mu into, right, substituting upper limit x square by 2, substituting lower limit. This is leading to minus u square by 2 is equal to minus mu into x square by 2. So minus minus gets cancelled, 2 gets cancelled, x comes out to be plus or minus root of mu square by, u square by, okay, x square is u square by mu. So x is equal to plus or minus u by root mu, you can write. This is the required one. Okay. Look at the next problem, that is 19th. A train starting from rest is accelerated as a is equal to 10 by v plus 1 meter per second square, where v is velocity in meter per second. Find time after which body attains a velocity equal to 54 kilometer per hour. 54 kilometer per hour is nothing but 15 meter per second. So after what time it acquires a velocity 15 meter per second. Okay. So if you observe the given data, at t is equal to 0, v is equal to 0, velocity is 0 starting from rest, and given that acceleration is equal to 10 by v plus 1, and what he is asking, that is also given data. I have to take t is equal to how much, such that final velocity becomes 15 meter per second. Means indirectly he is talking about relationship between velocity and time. Okay, I need relationship between velocity and time, means I have to express acceleration in terms of velocity and time. How to express acceleration in terms of velocity and time means I will make use of this equation. Okay, hence I can write a given one, a is 10 by v plus 1, but a can be written as dv by dt, that is equal to 10 by v plus 1. Separating the similar terms, v plus 1 into dv comes out to be 10 into dt. Now integrating on both sides. Okay, here initial velocity 0, final velocity should be 15, and starting from 0 seconds and the time when its velocity becomes 15 meter per second, I will assume it as t. Okay, then integration of this leads to what more, v square by 2 plus v from 0 to 15, that is equal to 10 is a constant, integral of dt means delta t. Okay, now this is leading to 15 whole square by 2 plus 15, substituting upper limit, minus of substituting lower limit leads to 0, that is equal to 10 into delta t is nothing but final point of time minus initial point of time. Okay, and this is leading to 10t, right. By solving this you will get t value, right, that is the required one. Now look at the next problem, that is 20. A train starting from rest accelerates according to that relation, okay, where v is given as velocity. Find the distance in which train attains a velocity equal to 54 km per hour. This 54 km per hour is nothing but 15 meter per second. Okay, here even though he is asking distance, here we are going to calculate displacement only. Why means the particle direction of motion is not changing. Okay, so here given data, if you observe, at t is equal to 0, u is equal to 0 we have. Second relation is he gave acceleration is 10 by v plus 1. Third one, what he is asking, right, displacement is how much if velocity acquired is 15 meter per second. Okay, so if you look at the situation, we have information regarding a and we need to calculate x. Okay, how to find out x from acceleration, isn't it? Now if you observe carefully, here we have the relations between a, x, v. So I have to think of the equation that is involving these three, that is nothing but only this equation. So in the place of a you have to write v into dv by dx, then simplifying you will get the required one. Okay, since a is equal to what we have, 10 by v plus 1, a can be written as v into dv by dx, that is 10 by v plus 1. Okay, then separating the similar terms you will get v into v plus 1 dv is equal to 10 into dx. Now integrating on both sides, right. Here velocity should be changed from where to where, 0 to 15, right. Here displacement I need, directly you will get, so no need of limits, right. So otherwise you can take x1 to x2. Then this is nothing but integral of 0 to 15 v square plus v dv, that is equal to 10. If I take out integral of dx refers to delta x, that only I need to find out. Okay, for v square integration is v cube by 3 plus v integration is v square by 2 from 0 to 15, that is equal to 10 into delta x. Substitute upper limit first, then lower limit, and you can calculate delta x directly. Okay. Now next one is 21. He gave the variation of position with time by this relation, and he is asking to find out retardation, where alpha beta are constants, x represents position. Okay, so he gave x and he is asking retardation, means indirectly he is asking acceleration. So this is known to us, we need to find out this, means you have to go for differentiation. Okay. In that process, first of all I need to find out velocity, then I can find out acceleration, thereby I can find out retardation. Okay. How to find out velocity means, we know velocity is equal to dx by dt, means differentiating x with respect to time you will get velocity. For that I have to differentiate this with respect to time. Okay. If I differentiate this with respect to time, for t 1 alpha, for x square what will get, 2x into inner derivative is dx by dt plus beta into for x differentiation dx by dt. Okay. But we know dx by dt is nothing but v, so this leads to this relation from which v comes out to be 1 by 2 alpha x plus beta. So I got v. Next I need to find out acceleration. How to find out acceleration means, differentiating velocity with respect to time you will get acceleration. So how to differentiate this, dv by dt, that is acceleration is equal to. Okay. But how to differentiate this means, if you observe carefully, it come under u by v form, means you have to make use of coefficient rule. Okay. Coefficient rule means differentiation of u by v with respect to dt, you have to write as in denominator v square, v into du by dt minus u into dv by dt. Okay. I have to make use of that principle, for which here this leads to denominator whole square means 2 alpha x plus beta whole square, and v means 2 alpha x plus beta into differentiation of u, here u is 1, that is constant, so its differentiation is 0, minus u value means 1 into differentiation of v, means differentiation of this one, differentiation of this one means 2 alpha into x differentiation is dx by dt plus beta is constant, so differentiation is 0. So acceleration we will get it as minus 2 alpha into, again this one I can write as v upon 2 alpha x plus beta whole square. Okay. But from this relation 2 alpha x beta plus beta is nothing but 1 by v. So this is leading to minus 2 alpha into alpha v into 1 by v whole square, which is leading to acceleration is minus 2 alpha v cube, thereby deceleration means minus of this means 2 alpha a cube, that is the required one. Okay. The next problem is problem number 22. Okay. He is mentioning the motion of a body falling from rest in a resisting medium as dv by dt is a minus bv, find velocity at an instant of time. Means he is talking velocity is how much if t is equal to some arbitrary time t. Okay, na? So he is talking about velocity and time, and in the given relation also we have velocity and time, so no modification is required in that equation. Only thing is we have to separate the similar quantities, that's all. So dv by dt is a minus bv, on separating dv by a minus bv comes out to be dt, then integrating on both sides to get the finite values. These limits are 0 to t. Okay. These are initially rest, final velocity is v. Okay. Now here you have to recall the formula for integral of dx upon ax plus b. Okay. For this we have log ax plus b upon a within the same limits. Okay. By making use of that formula, this leads to what? Log a minus bv upon a means their coefficient of x. Here in the place of x we have v, so I have to think of coefficient of v. Here coefficient of v is minus b, so that I have to write here from limits 0 to v, and integral of dt refers to delta t. Okay. Then here delta t is nothing but t minus 0, that is equal to t, which is equal to, here I can take minus b out, then minus 1 by b times log a minus bv 0 to v. Then t is equal to minus 1 by b times, substitute the upper limit first, log a minus bv minus substitution of lower limit log a minus v, in the place of v if you put 0, this whole thing becomes 0. Then minus 1 by v times log a minus bv minus log a, but in the form of log a minus log b. Log a minus log b is nothing but log a by b. So, I can write this one as minus 1 by b times log a minus bv by a. Okay. Then from this log a minus bv by a is equal to minus bt. From the definition of logarithm, I can write a minus bv by a is equal to e power minus bt. Okay. By solving this, you will get v value a into e power minus bt, make v as subject. Okay. That is about the required one. So, if you come to the next problem, here he is mentioning the position vector of a particle varies with time t as r bar is equal to r naught times t minus alpha t square, where r naught is a constant vector. Find the distance covered during the time interval in which particle returns to its initial position. Means what? If the particle starts from here in this direction with some velocity, okay, it has to travel like this and then come back to its original position in this manner. This is possible if and only if it has acceleration in this direction. Okay, na? In case if this acceleration is constant, you can take it granted that this time is equal to this time, isn't it? And of course, here he is talking about distance covered, means this length plus this length I need to find out. This is x if I take here, distance covered is nothing but 2x. Okay. So, first of all I have to think how to calculate x. Means one thing is clear that here its direction of motion is reverse, remains at that point velocity is equal to 0. Okay. So, I need to find out distance covered by the particle when its velocity becomes 0, right. How to find out distance covered by the particle when its velocity becomes 0 means this is a straight line path. So, that is nothing but displacement when velocity becomes 0. Okay. So, what is the given information? R bar is equal to R naught into t minus alpha t square, isn't it? So, here as this is a constant vector, magnitude of r I can write as r naught into t minus alpha t square. Okay. And if you observe, velocity means differentiating position with respect to time, that leads to r naught into for t 1 t square 2t. So, it comes out to be 2 alpha t, isn't it? But velocity becomes 0 means r naught into 1 minus 2 alpha t should be 0, means t should be equal to 1 by 2 alpha. Okay. So, as t is 1 by 2 alpha, what is the value of r that I have to see? That is nothing but x. So, x is nothing but r value when t is equal to 1 by 2 alpha. So, x is equal to, in this t is equal to 1 by 2 alpha, you substitute r naught into 1 by 2 alpha minus alpha into 1 by 4 alpha square, t square means. Then this gets cancelled, you will get x value. That is only the required one. Once the next problem is 24th problem number. A particle moving along x-axis has acceleration this much. At t is equal to 0, velocity 0 means initial velocity 0. Find velocity when acceleration is 0. Okay, na? Means first of all, at what time acceleration becomes 0 we will see. Okay. At that time what is its velocity we will find out, that is nothing but the required one. Okay. So, first I need velocity as a function of time. How to find out velocity as a function of time means given one, A is equal to A naught into 1 minus T by T. A can be written as dV by dt, that is A naught into 1 minus T by T. Okay. This is leading to dV is equal to A naught into 1 minus small t by capital T into dt. Then integrating on both sides, integral of dV, otherwise here itself. Okay. Initial velocity 0, final velocity v, initial time 0, final point of time arbitrary time t. Then integral of dV means delta v means final velocity minus initial velocity v minus 0, that is equal to, I can take A naught out as it is constant. Okay. Integration of 1 is small t, integration of t is t square by 2. So, the limits are from 0 to t. Then v leads to A naught times, if you substitute upper limit first and then lower limit, it leads to t minus t square by 2t. This is the expression for velocity. Okay. But I need its velocity value when A is 0. Okay. A is 0 indicates what? A 0 means A naught into 1 minus small t by capital T must be 0. That indicates 1 minus small t by capital T is 0. So, small t should be equal to capital T. Okay. Therefore, substituting capital T, small t value is equal to capital T here, you will get velocity when acceleration becomes 0. Therefore, v is equal to A naught times capital T minus capital T square by 2t, which is leading to A naught into t minus t by 2, that is t by 2. So, A naught t by 2, that is the velocity when acceleration reduced to 0. Okay. This is the required one. Now, the next problem, 25th one, a point moves rectilinearly with deceleration given by k root v, where k is constant. If initial velocity is v naught, distance covered by it before it stops, means as it is rectilinear motion, distance covered is nothing but displacement. So, I need to find out displacement when velocity becomes 0. Okay, na? So, I have to think of relationship between x and v. Okay. Given one is A is equal to minus k into root v, but I need the relationship between x and v, means I have to write A in terms of x and v. How to write A in terms of x and v means with the help of this equation. That equation leads to v into dv by dx is equal to minus k into root v times. So, separating the similar terms, root v into dv is equal to minus k into dx, integrating on both sides. Okay. This is leading to initial velocity v naught, finally it stopped means 0. Here initial position say x1, final position x2. Okay. Then for root v, integration is nothing but how much? V power, root v means v power 1 by 2. So, 1 by 2 plus 1 upon 1 by 2 plus 1, limits are from v naught to 0, that is equal to, if I take constant out, integral of dx, that is nothing but delta x. So, substituting upper limit and lower limit, you will get delta x value, which is nothing but the required one, isn't it? Here the next problem is, in the above problem, what is the time taken by it to come to rest? Means in the same problem only, instead of distance is asking time. Okay. So, the required one is how much? T is equal to how much, such that velocity should become 0. So, he is talking about velocity and time. So, I have to express acceleration in terms of velocity and time. How to express acceleration in terms of velocity and time? Okay, we have this problem. So, A can be written as simply dv by dt, that is equal to minus k into root v. Then separating similar terms, dv by root v is equal to minus k into dt, integrating this one. This is from 0 to t, this is initial velocity v naught, finally stopped means 0. Okay, na? Then this under root v integral of 1 by root v means that is nothing but integral of v power minus 1 by 2 dv I can write, whose integration is minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. Okay. So, it leads to v power minus 1 by 2 plus 1 means 1 by 2 upon minus 1 by 2 plus 1 means 1 by 2, from where to where v naught to v, that is equal to, if I take k out of the integral as it is constant, integral of dt refers to delta t is nothing but here t. Okay. So, substituting upper limit and lower limit, you will get the required thing. So, 0 minus v naught to the power of 1 by 2 by 1 by 2 is equal to minus kt, minus minus gets cancelled, from which you will get t is equal to 2 into root v naught. Okay.